Hi everybody, this is Sharavati. I am going to explain about the architecture of 8086 microprocessor. So here is what the block diagram of 8086 microprocessor looks. It contains two functional parts, bus interface unit and then execution unit. The bus interface unit is responsible for transfer of instructions, address and data on the system bus to execution unit. It handles the transfer of data between the processor, memory and I/O devices. It includes instruction fetch, data fetch, address transfer and computation of effective address of the memory. The functional part of bus interface units are instruction queue, segment registers and instruction pointer. Here is what the segment register part looks and the instruction queue. The instruction queue is of 6 bytes in length and it is used to speed up the execution of programs by prefetching 6 instruction bytes in advance from the memory, and the prefetched instructions are stored in a group of high-speed registers known as instruction queue. The bus interface unit works in parallel with the execution unit. The bus interface unit is responsible for fetching the instruction bytes while the execution unit will execute the instructions. This parallel processing is called as pipelining. Now let us see the segment register section. There are 4 segment registers: code segment, data segment, stack segment and extra segment. These registers are used to store the 16-bit starting address of memory segments. The bus interface unit will generate a 20-bit address using the segment and the offset component of the address. Bus interface unit can address the memory location starting from 0000H to FFFFH. Instruction pointer. It holds the address of memory location of the next instruction to be executed. It is similar to the program counter, that what we call in another way. That is, IP will always hold the address of next instruction to be executed. Now let us see the function of execution unit. The execution unit will work in parallel with the bus interface unit. It will guide the bus interface unit from where it has to fetch the instruction, and mainly it will perform the decoding function. It means it translates the instruction which is fetched by the bus interface unit into a series of actions or an operations. In other terms, we can say it is the execution unit is responsible to execute the instructions. The functional part of execution units are control system and instruction decode, which is used to convert the instructions which are fetched into a series of actions. Arithmetic and logic unit, flag registers, general purpose registers, stack pointer registers, finally pointers and index registers. Now let us see what is the purpose of instruction decode. As I told just now, it is used to translate the instruction fetched from the memory into a series of actions carried out by the execution unit. Now let us see why the arithmetic logic unit is being used here. So arithmetic logic unit is one of the main component of the execution unit. It performs all the arithmetic and the logical operations like addition, subtraction, multiplication and division, and also it will perform the logical operations like logical OR, logical AND, exclusive OR, NOT, complement, and also increment, decrement, and shift operations. Now let us look at the flag registers. Flag is nothing but 1-bit memory, that is what we know. Here 8086 microprocessor has 16-bit flag register. Out of these 16 bits, only 9 are the active flags. Here the flags are carry flag, sign flag, zero flag, interrupt flag, trap flag, direction flag, auxiliary carry flag, and parity flag. These are the 9 flags. We divide the flags into two types: conditional flags and control flags. Conditional flags are used to indicate the status of arithmetic or logical operations that what we perform, and the control operations will indicate the control status. Like we have three control registers: direction flag, trap flag, and then interrupt flag. Direction flag is mainly used in string related operations, and trap flag is used for single stepping. Then finally the interrupt flag is enabled if any interrupt is being requested by an external peripheral. Finally, let us see what are the different pointers and then index registers available in 8086 microprocessors. There are two main index registers which are present here, SI and then DI, which are used as index registers. These registers can be used mainly in different addressing modes for address calculations. We have the two pointer registers, stack pointer register and then base pointer register. Stack pointer and the base pointer registers are used as a pointer to the memory location, which is similar to the usage of the register BX. BX is called as a base register, which is also known as an other general purpose register. It is also used as a base register for address calculation along with SI and DI. So these are nothing but the brief overview about the 8086 microprocessor. So along with this, here we can see the general purpose registers or the data register section. We have 4 16-bit general purpose registers: AX, BX, CX, and then DX, which are nothing but a 16-bit registers. They can also be divided into two 8-bit registers, the lower 8-bit and then upper or higher 8-bit registers. We can name them as AL, AH, DL, BL, BH, CL, CH, DL, and then DH. All the other registers are of 16-bit wide. So these general purpose registers can be used for the temporary data storage or the address storage. So along with this, they are also used for the other purpose, like AX register is called as an accumulator, BX is used as a base register, CX most of the time we use as an counter, and DX is used to have the address of memory or the IO devices, especially when we do the interfacing. Thank you.